Welcome to our next video in the series of conic sections. Today we're talking about the hyperbola, starting with your definition. Definition is a set of points, P, in a plane such that the difference of the distances from P to two fixed points, called the foci, is constant. Simply put, if you put a point on your hyperbola somewhere, okay? Putting a point on your hyperbola somewhere. If you draw a segment to one focus and then to the other focus, and you subtract those two lengths, you will get a constant C. Let's say, for example, this minus this came out to be 5. That means no matter what point you put, as long as you put it on the hyperbola, if you draw a segment to each focus, the difference between those segments would be the same all the time. So if the difference between these two is 5, the difference between these two would also have to be 5. And you could pick a point anywhere on the hyperbola, the difference between those lengths would always be the same. Alright, so two equations. You have a horizontal orientation and a vertical orientation. These equations are very similar to the ellipse. One of the big differences to notice is that the ellipse has addition in between the fractions, and the hyperbola has subtraction in between the fractions. Now on the ellipse, a squared was always the larger of the two denominators. Well, that's not always the case with the hyperbola. On the hyperbola, a squared will be the denominator for the first fraction. Now you can tell the difference between the orientations this way. If the x's are first, so you have x's minus y's, the x direction is side to side, which means it has a horizontal orientation. If the y's are first, then the y direction is up and down, which is vertically. So if the y's are first, it has a vertical orientation. Now the other difference here is the ellipse equation over here was c squared equals a squared minus b squared. So one of the things you can do to keep it straight was on the ellipse, when you had plus here in between the fractions, it was a minus here. With the hyperbola, if it's a minus in between the fractions, then it's plus here. So these two signs are opposite of each other's. So, all right, next, the different parts of our hyperbola. A, B, and C still represent the same things that they did on the ellipse. A is your distance from the center to your vertices, so from here to here. B is the distance from the center to the co-vertices, which are here to here and here to here. And C is the distance from the center to the foci. And the foci are always going to be inside of your hyperbola. Now the ellipse had two axes. One was the major axis and one was the minor axis. The hyperbola also has two axes, but they're called different things. The transverse axis is the axis that runs from one vertex to the other vertex. So from right here to over here. That is your transverse axis. And then the conjugate axis is the axis that runs from the co-vertex to the co-vertex. So that's this direction right here. That is your conjugate axis. All right, and we do have asymptotes on this. The asymptotes you get by drawing a diagonal through the rectangle here and going through this way as well. All right, so that'll give us asymptotes that are hyperbola, curve, will approach but never cross. All right, so let's take a look at a few sample problems here and get going on this. First thing, A. A is underneath the first term. 25 is our A squared, so A is 5. B squared is always underneath the second one, so B is 6. C squared, you get from A squared plus B squared. So we're going to add these two values, giving you 61. And so since C squared equals 61, C would be the square root of 61. The center is HK, which will be 3, -1. And we're going to start right here, because that's where everything revolves around. 3, -1, your center. From the center, in the x direction, you're going to go 5 units, because 5 is the A value. X direction, go 5 units. So 1, 2, 3, 4, 5 to the left, 1, 2, 3, 4, 5 to the right. In the Y direction, you're going to go 6 units, because 6 is the B value. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 down here. All right, so your next step is to draw a box where those 4 points that we just plotted represent the midpoints of each side of this box. And I'm doing this as dotted lines because these are not actually part of the curve. All right, so your next step is to draw your asymptotes. Your asymptotes are the diagonals for this rectangle. And we extend these asymptotes outside of the box. Second one here. And if you draw these fairly well, they should intersect at the center. Okay. All right, so now the vertices. Well, since the x's are first in our equation, that means the orientation here is going to be a horizontal orientation. Horizontal orientation means these are your vertices and these are the co-vertices. So we have 8, -1, and -2, -1. Co-vertices 3, 5, and 3, -7. The slope of the asymptotes. Well, slope is rise over run, so that's from going from the center up and over. That's 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. 6 over 5. Well, 6 over 5 is the slope of this one. That's a positive slope. The slope of this one is a negative slope. Same numbers, so we're just going to use plus or minus 6 over 5. All right. Now, if you'll also notice, that is your B value divided by the A value. That's not a coincidence. Okay. All right, so your graph we can draw from your vertices approaching your asymptotes on each side of this box here. There's going to be a fairly wide hyperbola. And your foci you get from your c values, square root of 61. That's just a little bit less than 8. And we said the foci are always located inside the curves. So 1, 2, 3, 4, 5, 6, 7, 8. So somewhere around here. 1, 2, 3, 4, 5, 6, 7, 8. So somewhere around over here. That's where your foci are going to be located. And your domain. Your domain on this goes from negative infinity on the left until you get to negative 2, bracket because it's included. Union picks up again at 8 and goes forever to infinity on the right. Range goes from bottom to top, continuous, negative infinity, positive infinity. All right, let's take a look at this one now. Picking out the A value, we'll go a little bit quicker on this one. A value is 7, B value is 3. C you get from adding these two numbers together, which is 58, and then taking the square root of that. Again, that's C squared equals A squared plus B squared. Your center is at negative 2, 0, 0, negative 2. The K value always goes with the Y. So 0, negative 2 is your center, and we'll start right there. We go 7 units in the Y direction. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And 3 units in the X direction. 1, 2, 3, 1, 2, 3. Your next step is to draw your box, going through those points. And after you draw your box, you're going to go ahead and draw the asymptotes while we're at it. Okay. Now, the orientation on this one, since the Y's are first, this is a vertical orientation, which means you're going up and down. So that's a vertex, that's a vertex, this is a co-vertex, co-vertex. So your vertices, the coordinates are 0, 5 and 0, negative 9. Co-vertices, 3, negative 2 and negative 3, negative 2. Slope of the asymptotes, rising 6, running 3. 1, 2, 3, 4, 5, 6, 7. Rising 7 and running 3. And again, it's plus or minus because you got a positive slope and a negative slope. Now, remember on the previous problem, the slope was the B value divided by the A value. This time it is the A value divided by the B value. That's because we have a vertical orientation this time. All right, these are your vertices, so we can go ahead and sketch the curve going from the vertex, approaching the asymptotes on each side. All right, so your domain, negative infinity, infinity, both sides, left to right, it's continuous. Range, we'll have a union, negative infinity to negative 9 with a bracket, union, 5 to infinity. All right, next problem here. Information given to us, this time instead of an equation. This says write the equation of hyperbola if the length of the transverse axis is 20, the length of the conjugate axis is 12, and the center is at 2, negative 4. So let's start at the center. The center is 12. The center is 2, negative 4. It has a horizontal orientation. which means it's going to be opening left and right. Well, the distance from here to here, that is a vertex, that is a vertex. That is your transverse axis. It tells us up here the transverse axis has a length of 20. Well, if the whole thing is 20, that means the distance from the center to the vertex is 10. So we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 on each side of the center. The conjugate axis is 12. That's the other direction. So that gives us 6 on each side. 1, 2, 3, 4, 5, 6. And we're going to draw our box. And while we're at it, draw the asymptotes. All right, the A value from center to vertex, we said that was 10. B value from center to co-vertex, that was 6. A squared is 100, B squared is 36. Add those together, take the square root, gives you C value. And your hyperbola approaches your asymptotes on each side. And you can get your coordinates for all these things on the graph here. Domain on this one's negative infinity to 1, 2, 3, 4, 5, 6, 7, 8, negative 8. Union 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 to infinity. Range is negative infinity to positive infinity. And slope of the asymptotes, 1, 2, 3, 4, 5, 6. So what do you think? 6 over 10, which reduces to positive, negative 3/5. All right. And then the last one, we are given the graph and we want to come up with the equation for the hyperbola. All right, so A, that is a distance from the center to the vertices. That's a vertex, that's a vertex. 1, 2, 3, 4, 5. That distance is 5. B is the distance to the co-vertices, which would be here and here. 1, 2, 3, 4, 5, 6, 7, 8. This is A squared is 25, B squared is 64. 25 plus 64 is going to be square root of 89. All right, the center here is, let's see, 1, 2, 3, 4, 5, 6, 7, negative 7, negative 1. And you can get the coordinates on here for the vertices and co-vertices. Slope of the asymptotes going up 8 and over 5, so that's going to be plus or minus 8 over 5. And domain negative infinity to the vertex here, which is 8, 9, 10, 11, 12, negative 12. Union, let's see, this one is at negative 2 to infinity, and then the range is negative infinity, infinity. All right, hope this was helpful.